I will be talking on trends in products and manufacturing. My name is Venkanna Mittakola. I am working as a Senior Director, System Integration and Center of Excellence for Trane Technologies. What are the HVAC industry trends? These are the drivers which growth of the HVAC industry taking place in India and across the world. So I'll just go through each and every factor of these trends and give some brief how it is impacting for HVAC industry. You take a climate change, we all know that there is a year after year increase in ambient temperatures, and you would have seen that the customers are rushing to buy the air conditioners, and sometimes air conditioners are short during the summer season. Shelves are empty, the temperatures are soaring, the demands are rising. And environmental regulations, globally, there are regulations which are shaping the HVAC industry in terms of referents. What are the referents we should use which should not affect the environment, societies, communities? For example, in the past, we transitioned reference from ozone depletion potential reference to low GWP reference. Now we are talking, the reference should have can we get into zero OWP global warming potential reference? There are global regulations, country regulations are shaping the industry. And also, as we are getting into digital connected solutions, connected machines, connected systems, cybersecurity is very, very important, which should safeguard our machines, our industry, factories, and people. Cybersecurity is very, very important in these products and manufacturing. As just before 𝗟𝗲𝘁𝗀𝘀 talked about resources and talent, talent is very, very important, especially trained technicians who should be able to troubleshoot the machines in the harsh environments with the smart tools. There are tools which are accompanying talent resources. You just take the barcode of the machine and enter what is the problem in the field. It will give the solution how to address it. There are resources, talents are shaping up for industry. And critical situations during COVID, we have seen severe supply chain constraints, and then we are seeing some tariff trends. All this will make our industry, but industry always moves forward with the technology and innovations, whatever hurdles comes in. And the factories are moving to Industry 4 and 5. What is the Industry 4? Digital transformation of the industries, IoT technologies. Now we are talking about Industry 5.0, wherein human, environment, social is taken care, among all the digitization is happening. And the big picture here, digital transformation and connected solutions or systems, every machine is acting like a human with the intelligence, with the softwares and the hardwares put in the machines, which is connected across the globe, across the regions, and it is monitored. It is, you can do a performance check, you can do a troubleshooting, which is happening through, again, artificial intelligence and machine learning, which is the big trend in the industry, which is a very big push for HVAC industry current situation. And demographic dividend, economies are growing, and people, the population is growing, which is again pushing the growth of the industry. And energy efficiency, which is globally and regionally, there are the governing bodies making sure that our machines, our products are efficient year after year. For example, Bureau of Energy Efficiency in our country makes efficiency improvements every 2 years. For example, the efficiency of the products, if it is today 2.7 COP, it is going to improve to 3.2. So it is every alternate years energy is improving. These are the trends, global trends shaping our HVAC industry. I'll go to the next slide. Here I will talk about as the global trends pushing our products in manufacturing. I will talk about what is happening in the product innovation and technology trends. Here I noted 5 pillars here. In the product, energy efficiency, how the energy efficiency is happening, improvements are happening every year, efficiency of the product is improving. As I said, indoor environment quality in terms of quality of the air, in terms of the loads inside, in terms of the high efficiency buildings, the whole controlled, conditioned environment is improving, which impacting again energy efficiency. At the same time, there are global trends happening in electrification. We are seeing automobile vehicles are getting electrified. When we electrify, for example, you take a transport products which are runs on the diesel engines, have to get into the electrical systems wherein electricity will run the refrigeration systems. And also there is a trend happening globally during COVID time, the gas shortages wherein the heat pumps have to run on the electrification. If you compare heat pumps with electrification, which runs on the electricity, which is having a much more coefficient of performance compared to the induction heatings. Similarly, there are enough trends happening in energy efficiency in multiple ways, which is again impacting the decarbonization, wherein carbon footprint, which is impacting to the environment while running the product, is reducing. The carbon emissions of the product life cycle is reducing, which is a good sign. And another trend, as I said, refrigerant transitions are happening, which is ODP to low GWP refrigerants, low global warming potential refrigerants, which is we are moving from 410A to 454B, wherein the global warming potential 2000 odd GWP to 466, which is almost 70% reduction. And furthermore, the research and developments are happening to move to 0 GWP refrigerants. The refrigerants should also be selected in terms of highly efficient refrigerants, in terms of thermal efficiency, COP, in terms of chemical stability and safety, in terms of lubrication capabilities and highly thermal efficiency capabilities. So there are refrigerants transition is happening globally. As I spoke, connected systems and solutions, which is a great trend in improving the efficiency of the products and systems. All the products and systems are becoming efficient because which can adjust to the ambience, which can adjust to the occupants, which can adjust to the loads so that it can run optimally. Similarly, as the connected products and solutions, we can see the real-time performance of the product, which is like a digital twins, and we can do the tracing and is it running the best efficiency, or is there any challenges, or is there any issues, and we can correct them. Same way, a remote diagnosis. If any issue comes in, as the products are connected, you can diagnose remotely and you can maintain the product remotely, which is the technology is under development. And the other pillar, model-based system engineering, which is more specific to the engineering or product development, wherein the trends are we get the requirements from the customer, translate into the model, simulate the product, transform the requirements digitally to the factory, and the production will happen. So entire thread is digitally connected. So when we do that, the product cycle time will reduce. We can develop the products quickly, and we can trace if some issue comes in field, we can trace out why the issue is coming in, what are the parameters affecting, what is the simulation has been given the results, and how the test results is correlating. So you can do the product life cycle traceability throughout the product life. With this modular architecture, we can do a master product, and we can do a different capacities, different footprints very fast. With this model-based system engineering, we can also scalability and standardization of the components and scalability of the product, which becomes very easy. And I will also talk about how these trends of the product which is affecting the sustainability. We have a goal in our company, a gigaton challenge, wherein 1 billion metric tons of carbon footprint reduction through efficient products, efficient operations, which is scope 3, which is downstream and upstream. We are developing products and technologies to contribute, reduce the carbon footprint to the level of gigaton, billion metric tons of carbon footprint. We are also working on carbon neutral operations, net positive water, zero waste landfill. And we are also certifying our products, environmental product declaration, which is every product has been certified saying that how it is impacting the environment, be it carbon, be it materials, be it landfill, every aspects have been documented and certified. And we also do life cycle assessment throughout the life, what is the carbon impact to the environment. Coming to manufacturing innovations and technology trends, digital transformation in manufacturing, we all know, which is basically helping optimizing the manufacturing lines, reducing the takt times, linear manufacturing assemblies, and real-time manufacturing assessment. So while we gather the information, we can look at each station, how the throughput, what are the challenges, and how much production or productivity we can predict by real-time manufacturing database. And we will have a traceability of manufacturing in terms of, as we have the data of every station, what is the failure in a certain station. We can go back and correct in our system that it should not repeat, how many times it is repeating, so that we cannot move forward. So we will close the issues which never comes back. So traceability of the manufacturing is very easy with the digital transformation. Smart automation in terms of automating the lines, robotics, which are welding, assembling robotics, and AI-enabled operations and visual inspections. So there are machine learning and artificial intelligence stations have been built where it can give the instructions that the quantity level is reducing, so need to be filling, or it can visually inspect the component and say that yes, component is as per the standard, as per the drawing. So there are artificial intelligence in the operations is happening. As Mr. Jigasha talked about talent transformation, wherein the trainings are happening with the mixed reality systems, which is quick, efficient, and we can assess them and we can deploy them. And also the AI-enabled demand and deployment, which is helping, for example, we have to deploy certain number of operators. In operator is absent, it can quickly show what kind of the competency level is required, who are available for immediate deployment. So there are talent transition and demand deployment is happening through artificial intelligence. These are the trends which I would like to present for HVAC industry. Thank you very much.